Next, we are going to see power factor. Power factor. Already over the power consumed is equal to Vrms Irms cos phi. Vrms Irms cos phi. Here the power factor can be defined in the some ways. Here power factor means nothing but a cos phi. Power factor is nothing but a cos phi. That means cosine of the angle of leading or lagging. Cosine of the angle of leading or lagging. We know the angle pi between the voltage and current. That angle is leading or lagging. That means AC with the capacitor or inductor. So power factor is nothing but a cos pi. Power factor is nothing but a cos pi. That is equal to cosine of the angle of leading or lagging. Okay. Next we can define power factor is equal to R by Z. That is resistance by impedance. Resistance by impedance. And another way we can define power factor is equal to VI cos pi divided by VI. That means true power by apparent power. True power by apparent power. This is a way of defining the power factor. One is the cos pi, that is a cosine of the angle of leading or lagging, and the power factor is equal to resistance by impedance, and then power factor is equal to VI cos pi by VI, that is a true power by apparent power. True power by apparent power. And some examples of the power factors. So we know the power factor is equal to cos pi. So in that angle, cos pi, that means pi is equal to 0. Pi is equal to 0. Pi is equal to 0 means voltage and current is in phase. The angle between the voltage and current is 0. Okay. Angle 0, that means pi is 0, cos pi is equal to 1. Cos pi is equal to 1. It happening in the circuit of AC with the resistor. Happening in the circuit of AC with the resistor. Okay. And another one, the power factor is equal to cos pi by 2. Cos pi by 2. It happening in the circuit of AC with the inductor or capacitor. That is angle between the voltage and the current is plus or minus pi by 2. Plus or minus pi by 2. So cos pi by 2 is equal to 0. Cos pi by 2 is equal to 0. Okay. And then this power factor is lies between the 1 and 0. That means 0 and 1 for the circuit having resistor, inductor and capacitor in the varying proportions. In the varying proportion. These are the example of the power factor. Okay. First one, in the AC with the resistor circuit, voltage and current is in phase. So angle between the voltage and current is 0. If angle pi is 0, now cos pi is equal to 1. Next, in the power factor, angle is pi by 2. That means angle between the voltage and the current is pi by 2. It is happening in the circuit of AC with the inductor or capacitor. Okay. That means angle between these two is plus or minus pi by 2. We are getting 0. So power factor is lies between the 0 and 1 for the circuit having the R, L and C. Is having in the varying proportions. In the varying proportions. These are about the power factor. Okay. Next, advantages and disadvantages of AC over the DC. So there are many advantages and disadvantages of AC over the DC. First one, we see the advantages. The generation of AC is cheaper than that of DC. That means we can generate the AC with the cheap rate. Okay, when compared to the DC. And when AC is applied to the higher voltages, transmission loss is small when compared to the DC transmission. That means AC voltages easily can be transformed. In that case, energy loss would be small. Energy loss would be small. That means the transmission losses are small when compared to the DC transmission. Okay. And AC can be easily converted to DC with the help of rectifier circuit. With the help of rectifier circuit. This is advantages of AC. Next, disadvantages. Alternating voltages cannot be used for the some applications. That means charging of batteries, electroplating, and electric traction. So in that cases we cannot use the AC. At the higher voltages, it is more dangerous to work with AC than the DC. So at the higher voltages it will be more dangerous when we work with the AC when compared to the DC. These are disadvantages of AC with DC. That's all.